hasn't been the only obstacle the team had to overcome. In 2011, an outbreak of tornadoes cut electricity to the Marshall Space Flight Center in Alabama for nearly a week, while the team rushed to finish cryogenic testing on the primary mirror segments using power from diesel generators. Engineers had to endure a large snowstorm, known locally as Snowmageddon, while testing the Integrated Science Instrument Module at the Goddard Space Flight Center. And of course, everyone has had to contend with the global pandemic. One particularly memorable challenge was working through Hurricane Harvey in 2017. This massive cyclone dumped 40 to 60 inches of rain across the Houston area over a 4-day period, causing catastrophic flooding and $125 billion of damage, all while the telescope was undergoing cryogenic testing at NASA's Johnson Space Center. Though the telescope remained safe inside the test chamber, water leaked through the ceilings, people had to cover workstations in plastic tarps, food was in short supply, and a few team members trapped by floodwaters had to be rescued by boat. It was rough, to say the least, but the team and the telescope survived the storm. Despite winds and snow and endless rain, the team got it done, and Webb is now ready for its final journey atop a rocket into space.
While the Webb telescope is a technological marvel, everything here began with questions. Questions about how the first stars and galaxies came to be. Questions about whether planets around other stars might have environments that can sustain life. And of course, the promise of discoveries we can't even predict yet. A few days ago, I had a chance to speak with someone who's probably the best person on Earth to help us understand what we know, what we don't know, and how Webb will help fill in those gaps. Dr. John Mather is a Nobel Prize winner who measured the Big Bang with an observatory built here at NASA Goddard. John is Webb's senior project scientist, and we're so pleased to have you here today, John.
Good to be here with you, Michelle.
So to start this incredible story of Webb, let's start with something that's deceptively simple, gravity. There's something special about gravity.
Gravity is special. Gravity always pulls. It's the only force of nature that always pulls. So that's special. And what makes that special is that gravity, although it's very weak, is very long range. It can reach across the universe and slow down the expansion of the material that came from the Big Bang, turn it around, pull it back together, turn it into galaxies and stars, and eventually planets and a place where we could live. So that's what makes gravity special among all the forces of nature.
And something so simple, like just the idea that it's always pulling together, that simplicity leads to wonderful complexity, doesn't it?
Yes, because it's always pulling, it's possible for gravitational energy to be converted into kinetic energy, that's just heat, and the universe becomes self-heating, which is not something the other forces could do all by themselves. Clouds of gas can be compressed by the gravity until they get big enough and hot enough to light up and have the nuclear reactions inside that turn hydrogen and helium into the chemical elements you see around you, here in the house, here on the set. So carbon, oxygen, nitrogen, everything we have that we think of as ordinary came from inside stars. So we are stardust, as Carl Sagan told us, but there wasn't any stardust in the Big Bang. So we need this part of the story to be figured out. How did we come to be able to live here on our little planet when the universe started out without all of these goody things?
So you mentioned these planets around other stars. So we're almost sort of going through all these amazing science goals of the Webb. What can Webb tell us about planets around other stars?
Well, once in a while, a planet goes in front of the star, and some of the starlight goes through the atmosphere of the planet, if it has an atmosphere, on its way to the telescope. We will spread out that light into a spectrum, or what you would call a rainbow, and we'll analyze it to see what are the chemicals that are in that atmosphere. So we will be able to tell you, maybe, that's the plan, whether those little planets that might be like Earth actually could have, for instance, water in their atmosphere, and maybe enough water so there could be a liquid ocean under that atmosphere. One of the great questions. So we know they're planets. We know when we should look. We just don't know what we're going to see.
So after the Webb launches, one of my dreams is I'm going to be standing outside in my backyard and point to a star and say there's a planet around that star that we know has water vapor, oxygen, perhaps methane, carbon dioxide. So what is Webb going to also do in the search for life closer to home, our own backyard?
Well, here in our own solar system, we will be looking at everything from Mars on outwards to the farthest we can see. Satellites, comets, asteroids, and the planets themselves. And some of them are really interesting and special because we know they're possible homes of life. What would make a thing a home of life? Well, if it's wet, that's the good clue. So the satellite Europa, which orbits around Jupiter, was discovered by Galileo himself, and we know now that it has an ocean that's covered with ice. There are cracks in the ice where water comes spitting out. NASA are going to send a probe over there to fly through those plumes. We're also going to point over there with the Webb telescope to see what can see about that atmosphere and those plumes of water. We'll be looking at Titan, which is a satellite of Saturn, which is so big that it has an atmosphere enough to fly a helicopter. And it is cold out there, so that what they have, what is on the surface, is solid ice, and over that are liquid hydrocarbons, which you would use for fuel here in our home. But over there, it's liquid rain, lakes and rivers, and we will be looking at the geology of that before we send the helicopter out there.
So you're on this amazing journey from the very distant early universe all the way to our own solar system, but this has also been a personal journey for you. You've been working on Webb since the very beginning of the mission, is that correct?
I have. Since '95, we had our first conversation, but people were even dreaming and imagining way before that what we needed. And you could tell even before we launched the Hubble what were the possibilities, and we learned that we would need an infrared telescope that could do things that Hubble could not do.
Well, John, I've been an admirer of yours for many decades now, and it's an honor to be with you on this part of the mission. So thank you so much for joining us. Best of luck on the launch and the mission ahead.
And thank you for asking all these great questions.
The Hubble Space Telescope delivered profound insights about our place in the cosmos. But perhaps the biggest takeaway from Hubble is that we've only just scratched the surface. Hubble gave us the best ever views of stars and planets forming inside vast, dark clouds of dust. But as soon as we had that data, we were asking new questions that needed better measurements, clearer images. Hubble was also able to capture images from galaxies so far away. Their light took 13 billion years to travel to us. These distant galaxies are just tiny dots in Hubble's images, tantalizing scientists with clues about how the first galaxies formed. In order to pursue a better understanding about the earliest days of the universe, we needed to build a better time machine, and that's Webb. So I'm going to be rejoined here by Nicole and Macarena, and this is our chance to talk a bit about building that better time machine. You know, what about the technology of Webb? So there's so many aspects of Webb to start off with, but maybe again, going back to the theme of infrared. The design of this telescope is so different because we had to use infrared light, heat light. So tell us about some of the challenges of, for example, why does it have to be so cool? Tell us about infrared light in the design.
Right. Well, I think we've heard already just how cool it has to be. It's around or below 50 Kelvin, and that's minus 370 degrees Fahrenheit. Actually, below that is what it operates at. And that's very cold. And the reason we need it so cool is because we don't want the telescope itself to detect itself because there's several instruments on board. There's 4 different instruments, and there's some moving parts, and so you need things to be cool because you want to detect these faint signatures from either an exoplanet atmosphere or faint light from the earliest stars and galaxies. So you just don't want to detect your own telescope.
Now, Macarena, you are the instrument and calibration scientist for the coolest instrument.
It is the coolest
on Webb.
Yes.
MIRI. So tell us a bit about MIRI and why it needs to be so cold.
So MIRI, it's a really unique instrument, and it's a great example of this collaboration we have in this mission because it's half European, half US. And so MIRI is the only instrument on board that uses the mid-infrared light. And the mid-infrared light is a bit redder, a bit cooler than the near-infrared light, and so because of that, MIRI needs to be colder in order to detect that very faint signal from high-received galaxies or protoplanetary disks, etc. So because of that, it's the only instrument on board that has a cryocooler. So it is not only the passive cooling from the sun shield, it is active cooling. And it brings it down to about minus 450 Fahrenheit. So it's really extremely cold, a few degrees above the absolute zero.
And we were talking about you don't want the telescope to be so hot that it's basically giving off its own signal, its own radiation, and that leads us to why it needs to be in space, right? So tell us a bit about why do we need to launch this thing into space to see these wavelengths?
Well, again, it kind of goes back to atmospheres because Earth has an atmosphere and there's water in Earth's atmosphere as one example. I mean, there's a lot of other molecules, but basically in the infrared, at the wavelengths that we want to observe some of these stars and planets and galaxies, those wavelengths are actually where Earth's atmosphere is opaque. So with telescopes located on Earth, even at higher mountains where they try to get above the clouds or atmosphere sometimes, there's still residual atmosphere that we're trying to look through and peer through. So in order to see the full infrared wavelength range at a very high sensitivity as well, we need to go to space.
Absolutely. So we talked a bit about some of the power of techniques like spectroscopy. We've heard Dr. John Mather talk about it. So let's go a little bit more into the details of how spectroscopy works and why it's so powerful. Continue.
Oh, sure, yeah, I can keep going. Well, with spectroscopy, we heard, so visible light, again, is kind of, it's a rainbow of colors that we don't see naturally. But if you use something like a prism, you can separate out that light and see all the colors from blue to red. But then the infrared is redder than the human eyes can see. But you can still do the same technique where you have spectroscopy tools or instruments like Webb has, all these spectroscopic tools, so that we can break up the infrared light and look at certain colors, if you will, so that we can see certain features that we are looking for, whether it's the right wavelength where a galaxy might be bright or where water is absorbing in an atmosphere.
So Macarena, MIRI has many different capabilities.
It does.
And in fact, it has one that I believe is something different called Coronagraphy as well.
Yes.
Tell us a bit about all these ways that we're going to detect different signatures from planets. Tell us
So
about MIRI.
Coronagraphy, it's an amazing technique, but essentially it simulates an eclipse. So when we have a very bright star with planets around, for instance, usually when you take an image, the stars outshines the light of the planet, so you don't see them. But with MIRI and with other instruments, NIRCam as well, you can actually block the light of the star and dim it, and then you see the planets around. And it's really a technique that's going to be very much used and to do, like in this image, direct imaging of planets.
Well, thank you so much. We'll be back to talk to you more with some social media questions. Thank you very much.
Thank you.
NASA and its partners began developing the Webb telescope years ago, growing from an initial inspiration to a design, then schematics, and finally reality. What started as a big dream for studying the origins of the universe required best-in-class engineering expertise to transform into something real. Let's take a short look at the very long story about the earliest days of the James Webb Space Telescope.
Before the Hubble Space Telescope even launched, scientists were already discussing what should come next. Ideas for what was then called the Next Generation Space Telescope evolved throughout the 1990s, and by the end of the decade, NASA had a preliminary plan. Construction of the James Webb Space Telescope began in 2004. Beryllium was mined to create the mirror segments, which technicians polished and coated in a thin layer of gold. Meanwhile, engineers designed and built new science instruments in the US, Europe, and Canada. Every step of the way, there were reviews and tests to make sure each part could withstand the rigors of spaceflight. By the early 2010s, the team began bringing individual components together at NASA's Goddard Space Flight Center in Greenbelt, Maryland. It was there that the mirrors and instruments began to coalesce into the grand machine we see today.
We've said before that the James Webb Space Telescope is an incredibly ambitious mission. Big ambitions come with big challenges, and that's certainly been the story of Webb. From the beginning, the design of this observatory has been a balance between the boldest questions scientists have dared to ask and the cutting-edge technology that our best engineers could offer. The design for Webb evolved from earlier ideas of what a telescope could be, another example of the delicate balance between desire versus capability. To get a better understanding not only of the mission's goals, but also the mechanical guts of the observatory itself, I recently got a chance to speak with a pair of engineers who know the anatomy of the Webb telescope better than just about anyone. I'm here with Keith Parrish, a senior engineer on the Webb mission. And Keith, you brought something to show us today.
Yeah, yes I did. So conceptually, Webb Sunshield is actually quite simple. All we need is 5 tennis court size pieces of this material outstretched to protect the telescope from the sun. So what I have here is an actual sample of that material. This is just Kapton.
It's so light, yeah.
Yeah, it's an industrial, you can buy this and it's commonly used. And what we do is we buy it for Webb, we seam it all together in small pieces, and then we actually coat it with special coatings to give it what we call the thermal properties we need in orbit. So this one has a nice pink or purplish kind of hue to it. And the reason it's purplish in hue, we use this on the sun side. And we actually put a silicon material on this kapton, and then we actually put a little bit of a metal in it. And what that metal does is it gives us a nice electrical conductivity. We don't want any surface charging building up. And the other thing is this silicon coating actually drops the temperature of this layer. So, and also it's very durable and can survive, you know, for many, many years in space.
And then this whole thing has to unfold somehow. Where we can actually see that behind us.
Exactly right. So if you look at that animation there, unfolding there, so it's actually S-folded up. Almost like a fan. We call it S-folding. And once we get it all folded up, we secure it to a structure by actually pinning it for launch. So, you know, huge shout out to our mechanical engineer and our entire Sunshield team, because they've come up with some really clever ways to secure this for launch, unfold it, fold it, and then, you know, ultimately get it safely deployed in orbit.
That's wonderful. So speaking of unfolding and all these pins that need to release, let's go over here and talk to James Cooper. You're going to show us what's going on there.
Yeah, hi. So I have here an example of a non-explosive actuator. We have 178 of these.
These are all these little pins we're talking about, right?
James Webb, right?
Yeah.
107 of the 178 are the membrane release devices. And we use this type of actuator because it produces a very low shock when it's released. And the animation shows conceptually how it works. We send an electrical signal through either one of our connectors. We use both, but either one of them can cause the release to happen. It melts a small wire inside, and then we have a spring that unwinds and allows two halves of a split nut to separate, and then our pin can get extracted. And so in the case of the MRDs, it's a spring-loaded pin that pulls to release the folded membranes. In other places, we would be bolting two pieces of structure together and then releasing them so we can deploy them.
And the Sunshield itself has 107 of these?
107 MRDs that all have to work.
Every single one has to work.
Every single one has to work. and 178 of this type of device in various configurations around the entire observatory.
Right. Well, if we go over here, we've got something sort of lovely waiting for us, a big gold hexagon. So tell us what we're looking at, a sort of a model here of a mirror segment, right?
Right.
Yeah.
Full-scale, single segment, one of the 18 mirror segments on James Webb. The real ones would be machined out of a single piece of beryllium to the exact curvature we need. And then once we're deployed on orbit, each segment can be individually focused to make it act as a single perfect mirror.
Now that coating, tell us about this gold coating here.
Yeah, so this is you know, coated with a very thin layer of gold. It's only a few hundred atoms thick of gold, and that gold is really good because it gives us a reflective property in the infrared, and that's really what Webb is an infrared telescope, and we need that Sunshield exists to cool this entire telescope. So this mirror actually runs about minus 400 degrees Fahrenheit on orbit. If it were warmer than that, the infrared energy coming off of this, that heat energy would swamp our detector system and our instruments. So that entire Sunshield exists to cool all 18 of these down. And again, this gold coating is what helps with all that reflectivity to make it perform even better.
Well, that's wonderful. So now you put it all together, and we have a smaller mock-up here, the Sunshield, the mirror. Tell us what we're looking at here.
Much smaller. So yeah, this is our entire observatory fully deployed on orbit. And you can see the Sunshield here is a large feature. You can see all 5 layers that I talked about earlier. And it's the separation of those 5 layers which lets heat energy escape out to space before it eventually gets to this cold layer. Again, that entire telescope is running minus 400 degrees Fahrenheit, and the way we get it that cold is this side is shaded. The telescope is looking to the deep universe, which is near absolute zero. And then again, this layer here, we've got about a 500 degree temperature drop, so this telescope is also looking at this layer here, which is nice and cold. So that's what lets us, you know, harness thermal physics to cool this down to those really, really cold temperatures. Again, you can see our booms, which are fully deployed and stretching this out, and then ultimately all folds up and gets stowed into this structure for launch.
Right, so the membrane release devices would be along the back side of these structures on the forward and the aft side. And we release them in rows so that we can sequentially start to unfold the membrane once those pins are pulled out of the way.
Well, that's wonderful. Thank you so much for joining us, and best of luck on the launch. I'm very excited.
Yeah, thank you.
Thank you.
Okay, let's get a live launch status update from NASA commentator Rob Navius at the launch site. Rob, how are things in Kourou?
Well, thank you, Michelle, and Merry Christmas from the Jupiter Control Center here in Kourou, French Guiana. You are looking live at an Ariane 5 rocket on its launch pad, ready to send the James Webb Space Telescope on the initial phase of its journey. The fueling of the Ariane 5's first and upper stages began before sunrise, and in the last few minutes, mission controllers here in Kourou and at the telescope's control center at the Space Telescope Science Institute in Baltimore conducted polls, with all positions reporting they are go to proceed into the final phase of the countdown. Launch controllers have been monitoring weather conditions throughout the night, keeping tabs on clouds and wind speeds, both at ground level and in the flight path of the Ariane 5, ensuring that all of the precise commit criteria are acceptable for launch. Right now, we have a green board, no issues as the countdown proceeds, no issues again being tracked by the flight control team here in Kourou. By the way, our broadcast today is a collaborative effort between NASA and the European Space Agency. So that's it from now. From the Ariane 5 Mission Control here in Kourou, we'll be back with you soon. For now, let's go back to the Goddard Space Flight Center and Michelle Thaler.
Thank you very much, Rob. So Webb asks big science questions. It demonstrates astounding technology. It inspires and excites people to dream and wonder. And the spark of inspiration is the ignition of creativity. Kids all over the world have a natural affinity for Webb's big pursuits. And now we have a collection of young artists ready to showcase their work.
Hi everyone, I'm Kelly Girardi, and this is Delta V, and we're kicking off the Unfold the Universe Challenge with NASA and the James Webb Space Telescope. NASA is hosting an Unfold the Universe Art Challenge. Use your imagination to share what you believe the Webb telescope will find.
Gabriel, I am from Romania. This is how I imagine space.
Hello everyone, good morning. This is a drawing of distant galaxy that can be seen by James Webb Space Telescope.
Hi, my name is Anastasia, and this is what I drew, what I think the telescope will look like, what the telescope will see. I drew the Earth, the Sun, a new planet, a black hole, and stars.
So we've been fielding social media questions from viewers all over the world this morning, and let's take a couple of minutes to share some responses. There's been a couple questions about how long will it take for images to come out, and there's a lot of things that need to happen before the images are coming. So Macarena, why don't you take us through some of that?
Yes, so for the first scientific, beautiful images to share with the public, that'll take 6 months. And the reason is because it is, so we launched today, it takes a month to take to the orbit place, to the Lagrange 2 point, and then we have a whole period of cooling down the instruments, aligning the mirrors, and making sure that all the instruments are ready to do science. So the whole process takes 6 months, half a year.
And also all of those 18 segments of mirrors, something needs to happen to get them all working together too, right?
Exactly, because initially you launch with 18 segments and they work separately. So you will take, if you observe one star, you will get 18 little points. So there has to be a process where you take images with NIRCam, which is one of the cameras on board, start moving the mirrors slightly to make them work as a single one. And then by the end of this iterative process, you go from 18 points to a very sharp, pristine single point source. So all mirrors act as a single one.
So let's see, we have a question from LV coming in on Twitter. Will Webb be able to enhance detection of comets, asteroids, or meteors that enter our solar system? So that seems we've got a planetary person here.
Sure. Yeah, well, Webb does have a special observing mode where it's able to track these rapidly moving objects, because compared to these distant stars and galaxies, asteroids and comets, they move pretty quickly. And so Webb will be able to do this so that we can study material that's outgassing from them and learn more about what they're made of.
So let's see, there's so many good questions, and we only have time for a few more. So one is from Kristen Rodriguez on Facebook. How long will it take James Webb to reach Lagrange point 2? And you might also just explain what is Lagrange point 2?
So it takes a month. I think it's actually 29 days to get there. And the Lagrange point is this very interesting stable point. So the gravitational pull between the sun and the Earth create this point where it is stable, and you can, as we can see there, Webb can orbit around the L2 point in a very stable orbit, only needs a little bit of corrections once in a while, and it can always have the sun shield protecting the telescope from the radiation of the sun. In a full year, you can observe any object in the sky, and it's a continuous observation.
Well, thank you very much. We'll hopefully come back to a few more questions later.
Thank you.
So this is a big mission with a cast of thousands to bring it to life all over the world. As we get closer to launch, let's take a brief look at the main locations where Webb took shape on its journey to space.
Inside the massive high bay clean room at NASA's Goddard Space Flight Center, engineers assembled the 18 gold-covered mirror segments into the backplane of the telescope and integrated the 4 science instruments contributed by international partners. To simulate the harsh environment of launch, they went through vibration tests and acoustic tests. And to simulate a space environment, the instruments endured cryogenic testing in a large thermal vacuum chamber. But it wasn't large enough to hold both the instruments and the mirrors, so the telescope boarded a plane to Houston, Texas, to visit the only thermal vacuum chamber in the world big enough to fit the entire assembly. Chamber A at the Johnson Space Center was originally built to test the Apollo spacecraft, and half a century later, it provided a grueling 100-day test for the Webb telescope. Next, the telescope traveled to Northrop Grumman's facilities in Redondo Beach, California to meet up with its other half, the Sunshield and spacecraft bus. Fully assembled at last, the entire observatory went through yet more tests, many focused on making sure the spacecraft could properly fold up for launch and unfold in space. Then in September 2021, Webb caught a ride on a specialized cargo ship and set out on a 16-day voyage to the European Space Agency's spaceport in Kourou, French Guiana. According to its travel itinerary, that's Webb's last port of call on Earth.
Once Webb gets into space, we're going to have some exciting things to tell you about what happens next, from its extraordinary engineering to the thrilling scientific adventure it's about to enable us to undertake. But launch comes first. And for that, I'm going to turn it over to Katie Haswell, our host at the launch site, and one of NASA's most recognizable voices, launch commentator Rob Navis. It's all yours, Katie.
Thanks very much indeed, Michelle. Well, it's all looking very good here at the spaceport for a Christmas Day launch. Operations running smoothly, the countdown ticking over nicely. All the systems are green and we are go for launch. You can see there we're looking at launch pad number 3, the James Webb Space Telescope, inside the very top of the rocket in first class with its seatbelt on, waiting patiently for liftoff. That's scheduled in about 32 minutes' time. I'm in the Mission Control Center here at the spaceport, the nerve center of operations. We're about 10 kilometers from that pad, and behind me you can see it's a laser focus here in the control center with the mission control centers all on console there as we get closer to launch. We call this the fishbowl behind this protected glass. And up in their skybox here in Mission Control are NASA's Rob Navis and the European Space Agency's Luce Fabregat, and they're standing by to take over the commentary about 15 minutes as we get closer to launch. First of all, though, let's check in on the countdown and let's see how things are progressing with Stefan Israel. Stefan is the CEO of Arianespace. Arianespace is the company responsible for getting our telescope into space today. Stefan, thanks for joining us. No pressure.
Good morning, Cathy.
How are things looking?
So we are now 31 minutes before liftoff. So far, so good. Ariane 5 is ready. Webb is ready. The range is ready. And the weather is green.
Well, that's good to hear. So what can we expect to see? What's going to happen?
Yes, so in the 30 coming minutes, we will make the final operations. 10 minutes before liftoff, we will have the final authorization of the weather. And 7 minutes before liftoff, we will enter in the famous synchronized sequence.
And, I mean, how's everyone feeling? I'm guessing everyone's...
We launched for humanity this morning from the Guyana Space Center. You know what Webb is about. After Webb, we will never see the skies in quite the same way.
It's an important project, isn't it, for everybody?
It's a very special mission, but we have delivered already 111 times with Ariane. This is the 112 Ariane 5, so we will deliver this morning.
And everybody there in the control center, cool, calm, and collected. Stefan, thank you very much for having taken time to step out of the fishbowl for us, so you can head back now into the fishbowl and take up your position. Stefan Israel, thank you very much indeed. Stefan, of course, heads up what we call the flight desk, which is the authority that takes all the final decisions in the event of unplanned situations. Now, we are in French Guiana. We're on the northeastern coast of South America. We're in Amazonia. It's hot. It can get a little bit sweaty sometimes, and there are lots and lots of mosquitoes. But somebody who knows it very, very well is Raphael Chevrier. Raphael is a rocket scientist, or a rocket expert at least, from Arianespace. Thanks for joining us, Raphael. Tell us a little bit more about French Guiana.
Well, French Guiana is a French territory that borders Brazil. It's located in the Amazon rainforest. 97% of the land is covered in trees, so that's why it's so green and beautiful. And you can totally imagine that the wildlife there is absolutely incredible. This is actually one of the best preserved habitats in the world.
And of course, it is in the jungle, and yet it is actually the European spaceport. So what makes this location in South America so important and so relevant?
Well, there are several reasons for this. First, we are on the coast. It means that we can launch over the sea from north to east without having to fly over inhabited area. So this is very convenient to reach any kind of orbit. There is no hurricane here, big tropical storm, there is no earthquake, but more importantly, we are very close to the equator, so that we can benefit from what we call the slingshot effect given by the rotation of the Earth. So let me take this globe. Basically, here on the equator, we are all traveling at roughly 1,000 miles per hour. That's very convenient. Of course, we don't feel it. If we were on the poles, that speed would be very, very close to zero. It means that when Webb is right now on the launch pad, inside the fairing of the Ariane 5, it's already traveling in the right direction, and we can use this extra boost to get us into space. That's also very convenient for Webb, because doing so, it can save its fuel and increase its operational life in orbit at 1.5 million kilometers from here.
And that really is important, 1 million miles, isn't it? And so there's a real proper slingshot effect. Yeah. And the facilities here are ultra high-tech, and that's exactly what Webb needs, isn't it?
Yeah, that's very convenient for Webb. It's also located in a nature reserve. So this is the perfect meeting between nature and technology, and people come from all over the world to work here. But one thing that's been very important for Webb is cleanliness. Because you know that one speck of dust could alter the vision of the observatory in space. That's why we have been extremely careful in keeping a pristine environment in all our facilities, from Webb's arrival in French Guiana to sealing it inside the rocket.
So let's talk a little bit now about the Webb Space Telescope. I really don't think you need me to tell you that it is the product of a feat of human ingenuity. And you don't get to make a telescope as complex as the James Webb telescope and as remarkable without tremendous amount of collaboration. And the James Webb Space Telescope is indeed the product of a partnership between 3 space agencies who came together to create it, NASA, the European Space Agency, and also the Canadian Space Agency. So here to talk about that now is Greg Robinson from NASA. Greg, thank you very much for coming to the floor, out of the fishbowl as well for us. And we're talking serious teamwork here, aren't we?
Yes, Katie. We've benefited from an amazing partnership with the Canadian Space Agency and the European Space Agency. Over the life of the development, we've had more than 10,000 people actually touch Webb, 29 states in the U.S. and 14 countries across the globe. And not to mention the amazing industrial base across the globe that have benefited here. In order to do bold missions like this, it takes lots of resources and lots of expertise, so we maximize everyone's expertise.
And how did this bold mission get onto an Ariane 5 European launcher?
So as part of the partnership, the Canadian Space Agency contributed science instruments, and they're incredibly important for this mission. And so did ESA, science instruments, and the amazing Ariane 5 that we will see take us on this journey and put us in the right direction to get to Lagrange point 2, and we're looking forward to that.
It's a tremendous atmosphere here, isn't it, in the Mission Control Center? There's a real buzz here today. I wonder how you must be feeling, Greg. I mean, it's got to be a very, very emotional time knowing that your telescope is sitting there on top of the rocket, getting closer to launch.
It's certainly amazing. Often talk about the butterflies, and people keep asking me, have they started? Have they started? And yes, they're starting. And when we get to about 20 minutes out, they will start flying a lot. So
well,
the excitement is just amazing.
The excitement is building, and of course everyone very cool, calm and collected. Thank you, Greg Robinson. You can take your position back in the fishbowl now, because I know you've got a lot of work to do in there. Greg Robinson, thank you very much indeed for joining us. So the Ariane 5 launch vehicle is the heaviest lifter in the Ariane 5 Ariane family of launchers. And Raphael, she has got an incredible track record, hasn't she, of success?
Yeah, this is a very reliable and successful rocket. Webb is going to be the 112th Ariane 5 to be launched. And the very first Ariane, the Ariane 1, took off exactly 42 years ago. Yesterday, this was on Christmas Eve, 1979. Good symbol.
Yeah, and hopefully we're going to get a good Christmas present today as well. And I mean, the rocket is also, you don't get to build a rocket like this without collaboration either, do you?
Of course, just like Webb, actually. In fact, 12 different countries have been participating in the development of the Ariane 5, with Ariane Group now being the industrial prime.
And we have a scale model right next to you, Raphael. Why don't you talk us through it? The rocket is made of sections, and we often call those stages, which is what you might hear during the commentary.
Exactly. So first you have the 2 boosters, solid boosters, that are located on each side of the rocket. They will provide the main thrust in order to literally push the rocket against the gravity of the Earth. Then you have these big tanks that form the main cryogenic stage, with the main engine Vulcan at the bottom.
And then you have the Webb telescope right at the top, inside the fairing.
It is right there on the launch pad, and together they are put on top of the 3rd stage, a cryogenic stage, and it is this upper stage that is going to place Webb into orbit.
And what about the engines? What are we going to see at liftoff?
At liftoff, we first see the main Vulcan engine ignite first. We do this because we want to check it's working properly before we switch on the solid boosters 7 seconds later. Once it's done, there is no turning back. The rocket is going to lift off. And so, yeah, that's very... don't be surprised. Don't be surprised if you don't see the rocket lifting off for 7 seconds. That's time for the rocket to actually warm up before soaring into the sky.
So once we light the touch paper, you can count to 7 before it actually lifts off. Now, one of the advantages of the Ariane 5 vehicle is that it can be modified, and that's exactly what we've done for today's launch. We've had to make some changes for it to be able to host the Webb satellite. And joining me to talk about that is somebody who, the right person for the job indeed, because he was in charge of those changes, Daniel de Chambre from the European Space Agency. Thanks for joining us, Daniel. What did you have to do?
First, we need to recall that Webb will be the largest payload to be ever accommodated on I-5. It fully occupies the volume of the fairing, with gaps as small as 10 centimeters for a diameter of 5 meters. It is the reason why we had to develop a specific integration procedure to ensure that there is no contact with them. After separation, during separation, the venting system of the launcher has been improved in order to balance as much as possible the inside and the outside pressure of the fairing. And this is due to the fear of a depressurization shock, which could damage the delicate layers of Webb submersion shield. After separation, due to the fact that Webb, some equipment of Webb are very sensitive to sun exposure, the roll control of the launcher will be tuned in order to make sure that Webb is always oriented only one face to the sun. And in addition, to avoid any hot spot, the launcher will create some oscillating movements, like a barbecue mode, to avoid any overheating. And after Webb separation, there will be a specific end-of-life maneuver to be applied on the upper stage in order to put it on a liberation orbit around the sun in order to avoid collision in the long term.
Thank you very much indeed, Daniel. So we'll hopefully see the upper stage rocking in space. Not quite all the way around like the familiar barbecue, but a slightly different movement. Listen, gentlemen, thank you very much indeed for being with us today. I know that you're busy. You've got jobs to do inside the fishbowl, so I'm going to send you right back there now, and very best wishes for the launch. Thank you.
Thank you.
Our telescope has a long journey ahead of it. It's got to travel 1 million miles to its destination in space, its working zone, where it's going to start telling us all about our universe. It's already started that journey because it's traveled to the launch pad from Los Angeles. After final tests were concluded in Los Angeles, Webb was packed into a special container and transported along the LA 405 freeway, which had to be closed because it's so big. It traveled on a special ship. A lot of spacecraft will come to the French Guiana launch site by plane, but Webb was too big for that, so it had to travel by ship, and it went through the Panama Canal. Up through the locks. And it took 16 days to get to the port in Kourou, where it was unloaded and traveled to the spaceport. That's not the real Ariane 5, that's a model, just outside the Jupiter Control Center, actually. It was unpacked very carefully in the facilities that Raphael was talking about. And then fueling started, and of course, the teams had to wear special suits because that's a dangerous job. And then it was placed all the way on top of the Ariane 5 rocket. It was encapsulated inside the fairing and sealed, and then it was rolled out to the launch pad 2 days ago. From the vehicle assembly building to the pad along very special rails. Very, very slowly through the Amazon rainforest. It was raining at the time, and that was 2 days ago, and here we are now, 17 minutes and 46 seconds to launch and counting. All systems are go here at the European Spaceport in French Guiana. We have 3 control centers on the job today. We have the Mission Control Center here. We also have the Launch Control Center, which is about a mile from the pad. And then we also have the Telescope Control Center, Mission Control in Baltimore in the US, and that's where the operational teams are standing by to take over the telescope operations. Once it's released from the mothership, that will be about 27 minutes after launch. And they'll be controlling the Webb telescope for the rest of its life. Very important job. The James Webb Space Telescope is a truly remarkable observatory. People have been working on it for over 2 decades. Some people have been working on it for their whole professional lives. Thomas Zurbuchen is the head of science at NASA, and he's joining me now just to talk about it. Thomas, or Dr. Z, as we can also call you. The day has come. All these decades, all this time, all these people working on the telescope, and here we are, 16 minutes and counting to launch. It's a big day, huh?
Oh, I'm so amazed, right? We have this telescope on top of this rocket, a telescope that 10,000 plus people have worked on in many ways, and together with that telescope, all the hopes and dreams of those individuals, and also tens of thousands of scientists, some of them not even born, that will benefit from these data, are there with them, waiting for these last minutes of countdown for its journey to space.
I'm guessing people are feeling a combination of emotional excitement. What's going through people's minds, do you think?
Oh, I think there's a tremendous sense of accomplishment. Whenever you're on top of a rocket, many things went really, really well. There's tremendous pride. There's always a little bit of anxiety. We know launching is hard. We have one of the absolute best teams in the world working on this right now, so I'm confident in that. We're super excited. I mean, it's just an amazing day today.
And what are you most excited about, Dr. Z?
Well, I'm a scientist, so for me, besides the technology that really is a marvel, I mean, it's really the best we can do. What I'm thinking about is really looking at the universe in new light. We have never seen the universe how Webb will show it to us. And can you just imagine going back in time, 13.5 billion years? It boggles your mind, even as a professional astrophysicist. Kind of just think about all the new things we're going to learn about our most beautiful universe.
Dr. Z, thank you very, very much for joining us. And I want to wish you and all the teams, everybody, the very best for today's launch. Thank you.
Go Webb.
So, yes, indeed, go Webb. So we are now 14 minutes and 30 seconds to launch. We're getting really close now. Everything's going well. All systems are green for launch. And I'm going to hand you over now to NASA's Rob Navius in the skybox alongside the European Space Agency's Luce Fabregat, who are going to take on the commentary from here on in. Over to you guys. Rob.
Well, thank you, Katie. Merry Christmas to our worldwide audience from our broadcast booth high atop the Jupiter Control Center here in Kourou. Joining me today for this historic launch, my colleague Luce Fabregat, the head of infrastructure and value chain for the European Space Agency. Luce, good morning.
Good morning,
to be with you. Great to be with you today.
Very pleased to be here with you and all of you watching us for this very special event.
Well, at this hour, countdown clocks are ticking backward. We are at T-minus 13 minutes, 32 seconds and counting. Out on the launch pad, everything is in great shape. Don't let those clouds fool you. We are go for launch. The latest weather briefing just completed indicated that all weather parameters are green. We have a green board here in the control center, and everything has gone extremely smoothly in the countdown. About 9 minutes ago, a major milestone passed as the James Webb Space Telescope began the process and completed the process of receiving commands to transition from external power to internal battery power following the latest in the series of those weather briefings. Webb will remain on internal battery power until its singular solar array unfurls about 30 minutes after launch. Earlier, telescope controllers reported good environmental readings from sensors inside the fairing, encapsulating the telescope atop the upper stage of the Ariane 5 rocket. And Luce, as we enter the most critical phase of the countdown, can you outline
Bun, hai că am dat și drumul
some
la
of the
microfon să mă
upcoming
auzi și pe
critical
mine acum.
activities as we
Și
head
o să vă
into
dau
the
drumul și la web,
phase
probabil.
called synchronized
Nu mi-am spus puțin asta pe
Yes,
birou
Rob.
aici, scuzați
We are now
gălăgia.
reaching the end of this 11 hours
Sper că mă
sequence
auziți,
that
da?
we call the chronology, and that started yesterday evening. All systems here have been prepared for the final launch operations. And
Viața 100% va găsi acolo, fie că e microbiană, fie că e altfel de viață biologică, dar trebuie să găsească. Telescopul este mult prea avansat. Mult prea avansat.
That the launcher fluids and electric systems are ready for the final automated sequence. They are on hold now, waiting for the last weather report at minus 10 minutes. After this weather report, 3 minutes later, we will have the beginning of this famous synchronized sequence when all systems will be made ready for the liftoff. This sequence will first be run by the ground calculator, and then the onboard computer will take the lead step by step, and the launch vehicle will be made autonomous from the ground
Bun.
system.
Da, da, cam încet, dar da. Ok, 2
You know
secunde
that
mă dau
we have
puțin mai
two
tare.
tanks in each cryogenic stage, upper stage and main
2
stage.
secundele.
All 4 tanks are
Ok, acum sper că se aude mai bine, că nu vreau să aud foarte, foarte tare, că vreau să aud ce spune
we have here in French Guiana. However, this
și oamenii aici de la
propellants
control
are
center.
at very
Păi,
low temperature, and
acum e mai ok,
because of
nu?
that,
Sper.
slightly evaporate. And to ensure they are perfectly loaded at liftoff, their final loading and topping up will last up to 4 minutes before the launch. So that will be the beginning of the synchronized sequence.
Telescopul va ajunge la Lagrange position, adică o poziție între Pământ și Soare, care de fapt o să orbiteze partea exterioară a Pământului, undeva pe la aproape de 15 milioane de kilometri de Pământ. Sau poate chiar 7 milioane, depinde cum sunt traiectoriile acum. Dar când va ajunge acolo, trebuie să va dura în jur de vreo 2 luni până va ajunge acolo, o lună sau 2 luni până va ajunge acolo. După o să mai dureze încă 3 sau 4 luni până telescopul o să fie pus în poziția necesară pentru a putea detecta și alte planete, stele, galaxii și etc. Te referi pe Proxima B sau ce va găsi viața în general? Pe Proxima, cred că pe Proxima B este cea mai apropiată de sistemul nostru solar, deci practic s-ar putea să găsească. Nu uitați să pasați și voi butonul de like, să fim aici în trend. Și să ne bucurăm cu toții de acest eveniment minunat, pentru că e un eveniment unic pentru istoria omenirii și sper că totul va decurge conform planului și nu vor fi probleme. Doamne ajută, sperăm să fie bine, pentru că e important. Mi-a făcut un train cald să fim aici.
Seated with mission controllers on the floor of the control room is Raphael Chevrier of Arianespace. Raphael, how's everything looking? What's being discussed down there?
Hi, Rob. Well, so far so good. We just received the last weather forecast. It's all green for the H0 that is forecast right now. What we checked was altitude winds, wind in the vicinity of the launch pad, and risk of lightning. So right now, it's a relief because the weather was a bit tough in the last couple of days, but right now everybody is very focused on the next steps. The start of the synchronized sequence at 7 minutes.
Proxima 100% va găsi viață și eu sper să găsească viață, pentru că nu neapărat că e important pentru noi, dar e important pentru toată istoria omenirii și sper să fie bine totul.
Thanks, Raphael. We'll be back with you and Luce here shortly. We now have confirmation from Baltimore that James Webb is on.
Crede-mă că eu aștept lansarea telescopului James Webb de vreo 4 ani de când o aștept și au fost anulate de vreo 5 ori. Și acum că într-un final se îndeplinește chestia asta cu lansarea telescopului James Webb, pentru că a costat o grămadă de bani, în jur de 10 miliarde. Crede-mă că sunt mai nerăbdător să văd lansarea telescopului James Webb decât mai aștept Revelionul. Pentru că Revelionul avem de an în an, dar lansarea telescopului se întâmplă o singură dată într-o viață, două. Deci
Genesis of
să sperăm că totul va fi
new
bine
era
și va decurge conform
discovery.
planului.
The launch of the James Webb Space Telescope.
Nu uitați să apăsați și voi butonul de like acolo, să facem mai multe like-uri și sperăm la mai bine, domnește.
All the critical calls from the DDO, the Range Operations Manager, who is Jean-Luc Voyer, here in the in the Mission Control Center. There he is. He will be calling the start of synchronized sequence.
De 2 ani, bravo,
all of the
bun,
critical
super tare, de 2 ani e destul de
milestones.
bine.
We will
Și
be,
vă mulțumesc tuturor
listening
membrilor, că
intently for his
avem în
calls.
total de 6
Stand
membri.
by.
Vă mulțumesc foarte mult că mă susțineți și pentru că sunteți aici cu mine și încercați să mă susțineți nu doar prin subscribe și să fiți și membri. Vă mulțumesc din suflet. O să veni număr pe rând. Mădălin, Chirian, mersi pentru membru, Gigi FCSB-ro, mersi pentru membru, Udrea, mersi frumos pentru membru, Manaș, apreciez, Dan, Boriciuc, mersi la fel, mersi pentru membru și George Gască, mersi pentru membru de 10 luni, tu ești cel mai longeviv aici pe canal, mulțumesc frumos, apreciez susținerea ta foarte, foarte, foarte mult.
150 tons of liquid oxygen.
Dar vom avea și mai multe informații despre gaura neagră din centrul galaxiei. Despre gaura neagră din centrul galaxiei noastre te refer la Sagittarius A star, la Sagittarius A, de fapt. Da, o să fie interesant. Eu aștept cu nerăbdare, v-am zis, aștept să fie lansarea asta de foarte mult timp. De unde e Ariane, compania asta? Nu e Ariane, este nava în sine, racheta, Robert. Racheta se numește Ariane 5. E una dintre cele mai sigure și cele mai performante rachete în momentul de față.
To a highly elliptical, halo-like racetrack orbit some 1 million miles from Earth to begin its scientific observations.
In a little more
Ariane
than 1 minute
5.
from now, we will see the 4 tanks pressurized at their flight
Compania în
level
sine se
for the
numește,
last test
nu,
before the
stai cum e aici la
ignition of the
companie.
Vulcan engine.
Nu mai știu cum e aici la companie, dar Ariane 5 e însăși racheta, așa se numește, Ariane 5. Dar e foarte interesant, abia aștept. Hai că nu mai durează mult.
1 minute before the launch, 1 minute and 5 seconds before the launch, and we are going to see minus 6 seconds. At minus 6 seconds, we will see the disconnection of the upper stage, these big cryotechnic arms you can see on this picture. Then, 3 seconds before the H0, the inertial platform that will give all the information about where it is to the launcher will be released. And at H0, the 7-second sequence to ignite the Vulcan engine of the main stage will start. That will take 7 seconds, a little less than 7 seconds, where the engine will start up to its flight regime. And once the computer has checked that the Vulcan engine is running normally, and you will see at that point a flame going stable at the outlet of the nozzle, and at that point the onboard computer will ignite the 2 boosters that will enable to move the 770
2 secunde dau share la live și pe canalul nostru de Discord.
Coming up on the T-4 minute mark right now. Just a couple of
Eu cred că este un mic Planeta Nouă. Nu cred. Am făcut un clip despre Planeta Nouă. Îl aveți pe canalul de YouTube. O să vă uitați pe canalul de YouTube. Avem un clip interesant despre Planeta Nouă. Dacă telescopul va fi lansat cu succes și toate se decurgă conform planului, da, e posibil să descoperim și cu adevărat dacă există sau nu Planeta Nouă în sistemul nostru solar. Sperăm că totul va fi bine și lansarea va fi cu succes.
That will expose the James Webb Space Telescope to the environment of flight for the first time. The main stage separation, or the first stage separation, comes at the T-minus at the 8-minute 47-second mark into the flight, and that will be about a 16-minute burn of that upper stage engine. It will cut off at about 24 minutes 51 seconds into the flight, and then we'll go into a coast phase of about 2.5 minutes to allow any oscillations to dampen out, provide the most pristine environment for the James Webb Telescope before observatory separation. We're coming up on the 2-minute 50-second mark into the flight, Again, you're
avem
going to be
puțin.
hearing critical calls down the stretch here from the DDO, or the Range Operations Manager, Jean-Luc Voyer. The weather is go. We have a green board, no issues being worked. NASA officials, including Greg Robinson on the right, carefully watching
Bun,
the
sperăm că ne vedem și
telemetry,
aici. Lăsăm
looking
aici în colț.
intently at the final couple of minutes of the countdown. Lives have been spent in the preparation of the James Webb Space Telescope that is about to fly.
O adevărată mașină a timpului este acest telescop. Cu adevărat, să știi. Chiar este ca o mașină a timpului și... Adică o să vedem în trecut.
And that is the DDO, the Range Operations Manager, Jean-Luc Voyer, as we have hit the 2-minute mark in the countdown.
Scuzați-mi fața, dar abia m-am trezit pe la 11 și ceva. Abia acum un sfert de oră, 20 minute am mâncat și am venit direct la aici să stau de vorbă cu voi.
During the solid rocket boosters phase, that will be the atmospheric part of the flight, the atmospheric flight, and the trajectory will be driven by a to reduce the aerodynamic loads, and we will have a very different exo-atmospheric flight after that.
And you were watching a number of people, VIPs and invited guests, moving out to the observation platform
Dar mi se
that
pare că
is
avem
right
ceva delay
next
parcă pe la
to the
stream,
Jupiter
nu?
Control Center, as we stand by for the 1-minute call from Jean-Luc Voyer.
À tous les DDO, attention pour moins 1 minute.
Haideți să vedem, mai avem un minut.
À 0 moins 1 minute.
Noi suntem înainte cu 20 de secunde.
We're inside a minute now, T-minus 50 seconds and counting. As you heard earlier, the Vulcan 2 engine will ignite. Turbo pumps will come up to flight speed for 7
Da, îmi bate
seconds.
soarele în față, că e lumină de la soare direct aici. Crăciun fericit și mult succes. Mersi la fel, Udrea.
T-minus 30 seconds and counting. Standing by for terminal count.
Închidem countdown-ul și imaginea și gata.
À tous les DDO, attention pour les décomptes finales.
Numărați cu mine că trebuie să urmeze.
9, 8, 7, 6, 5, 4, 3, 2, unité, top.
And we have engine start. And liftoff.
Décollage.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight. Good pitch program reported.
Trajectoire nominale.
Vehicle performance is nominal. The Ariane 5 rocket continues to fly uphill in nominal fashion. The rumble of the powerful Ariane 5 now being felt here in the control center. 3D animation.
Avem și animație 3D aici.
We can hear the noise and feel the vibrations here. You're right, Rob. Yeah, impressive.
O să dureze 1 minut și 30 de secunde până va ajunge în exosfera planetei ca să desprindă.
Les paramètres à bord sont normaux.
The trajectory reported to be nominal by Jean-Luc Voyer, the Range Operations Manager. You can see at the bottom of your screen the yellow line is the trajectory plot, perfectly overlaid over the green line, which was the pre-launch trajectory. 1 minute 41 seconds into the flight, about 40 seconds away from
cam în oră, da, e cam în oră, dar e bine, e bine. E bine.
Coming up on the 2-minute mark into the flight.
When it detects the threshold on acceleration, not the deceleration, but less acceleration for
Les paramètres à bord sont normaux.
everything is okay. Everything
Acum
is
trebuie să
normal.
se pare în următoarele
2 minutes, 15
10
seconds
secunde.
into the
9,
flight.
8,
When the computer
5,
detects this
4,
threshold,
3, 2.
it will separate.
Bun. S-a separat acum.
Séparation des EAP.
Done.
We have confirmation of solid rocket booster separation from Jean-Luc Voyer.
Bun, acum trebuie să
It's coming at
stabilizeze.
an altitude of 44 miles. The Ariane 5 and James Webb traveling almost 5,000 miles an hour. We have about
Când
1
vom avea
minute,
peste
5
6 luni,
seconds to
probabil.
go before fair
Dar vești o
comparison.
să vă aduc în
That'll be the
continuare
next
despre
critical milestone.
starea telescopului James Webb.
The fairing is there to avoid the satellite being exposed to high temperatures and also high airflows. And as soon as the launcher leaves the atmosphere, as is now the case, the satellite does not need anymore to be protected, and Webb does not need anymore to
Încă
be protected.
15 secunde până la a doua separare.
Kilogram
14,
being very
13,
important for the performance of the launch,
11,
we are
10,
going to eject
9,
this no more useful fairing.
6, 5, 4,
And let's go down to
3,
the floor in the
2,
Jupiter Control Center
1,
to Raphael
0.
Chevrier of Ariane Space. Raphael,
Acum.
so far so good.
Hi Rob, so far so good. Everything
Bun.
is nominal, as we say, when attitude and trajectory of the Ariane 5 is going perfectly well. As you can see also on the yellow line
Langage de la coiffe.
on the screen, we had the confirmation of the separation of the two solid boosters and now of the fairing, meaning that we have crossed the limits of the atmosphere. So everything is going
Tous les paramètres à
super
bord sont
good.
normaux.
And the DDO just said that all parameters are going perfectly smoothly. So let's continue the mission.
And Raphael, this is a view from the upper stage camera called the Vicky Cam, looking back at the James Webb Space Telescope. This is
Mai trebuie să mai urmeze o separare.
or so because of the way the imagery is processed here in the control room. There's your telescope ready to unfurl its wings basically and begin its journey to the Lagrange point, the L2 point, about
O
a
să ducă
million
la punctul
miles away
L2.
from Earth.
Sunt 10 miliarde în joc. Da, Cristi, sunt 10 miliarde de dolari în joc.
La trajectoire est nominale.
Trajectory is
Sperăm că o să
nominal,
fie
the
bine.
report from Jean-Luc Voyer.
Să sperăm că tot o să decurgă conform planului și nu o să fie probleme. Asta e important.
The liftoff time confirmed here in the Mission Control Center at 12:20 Greenwich Mean Time, 9:20 a.m. Peru time, 7:20 a.m. Eastern Time. The Ariane 5 and James Webb, 181 kilometers in altitude, 450 kilometers downrange from the launch site here in Kourou.
Bun. Măcar lansarea a fost cu succes. Lansarea a fost cu succes, asta e un pas foarte important.
5 minutes, 12 seconds into the flight. We have about 3.5 minutes to go in main stage or first stage performance. And again, you can see at the bottom of your screen the
Ce mă
yellow
enervează că îmi bate lumina
line
direct
overlaid over the green
în
line,
cap.
meaning we are right on course, right down the pike, and a perfect trajectory so far for the Ariane 5
Les
rocket.
paramètres à bord sont normaux.
All telemetry data are now received by the Galileo tracking station, which is close to here, where we are.
Mai sunt 2 minute și, de fapt, 1 minut și 10 secunde până la penultima separare.
The ignition of its upper stage.
Pilotage calme, la propulsion est nominale.
And then we'll have the natal station in Brazil. Ascension in the, as you can see on the map, in the middle of the
Nu
ocean.
uitați să apăsați și voi butonul de like, să facem și noi, poate ajungem la 100 de like-uri, ar fi foarte interesant. Și vă mulțumesc foarte mult că stați cu mine aici și urmărim împreună acest eveniment minunat, unic, să zic așa. Cine știe când s-o mai lansa un următor telescop în spațiu.
Malindi station, and this Malindi station will also acquire the telemetry data from the telescope. You can see both are green, Galileo and Natal on this animation. It means they are expected to receive the data, and it was confirmed right now by the launch operations manager.
Acquisition de la télémesure par la station de Natal au Brésil.
And just confirming now that telemetry is being processed through the Brazilian tracking station. The telescope is also processing telemetry through the tracking and data.
Păi durează pentru că o să dureze ceva timp, cam o lună, până ajunge la Lagrange position, la L2. După o să mai dureze până își dea unfold la toată la toate dispozitivele și tot solarul sail-ul ca să poată să are un diametru foarte mare al oglinzilor. Vedem și noi de pe rachetă niște imagini. Sperăm că ne dă acum niște imagini cei de la NASA.
It will be jettisoned, and just a few seconds after that, the upper stage engine will ignite, and it will be the workhorse for a 16-minute burn that will put James Webb into its preliminary orbit.
Poate să descoperi teleportarea. Nu avem nicio treabă cu teleportarea în videoclipul ăsta. Teleportarea cred că o să fie descoperită peste 1000 de ani.
Telescope controllers at the Space Telescope Science Institute will be sending commands to prepare James Webb for the initial series of commissioning activities that will lead to the deployment of its solar array.
Până își calibrează oglinzile, până își calibrează toate sistemele, să-și bage toate sistemele în funcțiune, o să dureze probabil între 3 și 6 luni. Dar și când o să fie lansat în întregime și totul o să fie decurgă conform planului, o să avem ocazia să vedem ceva unic și spectaculos. Acest telescop, James Webb, are puterea să vadă în infraroșu, adică gen o să străbată prin nebuloasele spațiale. Haideți că urmează penultima separare. După, vedem ce se întâmplă. Penultima separare e una dintre cele mai importante, pentru că trebuie să funcționeze motorul de propulsie exterior.
Extinction de l'EPC.
Hyperloops creat de cine? De către Elon Musk? Nu uitați să apăsați și voi butonul de like acolo. Suntem 65 de like-uri. Haideți cu încă 35 să facem 100. Dacă se poate. Dacă nu se poate, asta e treaba. 2 secunde să scot traducerea de acolo. Bun, s-a produs separarea.
Very important moment for us because it's always a challenge to switch on a cryogenic engine in space condition, and we are now at 220 kilometers of altitude. Speed is a bit more than 7 kilometers per second. As we enter now the second stage of the second phase of the flight, the upper stage is going to power for about 16 minutes to place Webb on its transfer orbit, and right now everything is again nominal.
Nu, burtica asta e a mea. Asta nu e burtică de la mâncare prea mult. Am mâncat adinoarea și sunt umflat. Lăsați-mi burtica în pace, vă rog frumos. Și acum încă e mică, deci trebuia să o vedeți în întregime. Nu, 2 secunde. Acum e mai decentă, e mai ok. Dar acum câteva luni trebuia să o vedeți în întregime, era full power. După o să vă arăt și geaca mea, să-mi ziceți dacă vă place cum a ieșit. Bun, s-a făcut și penultima separare. O să urmeze ultima separare, cred că în 30 de minute, dar nu o să mai stăm live noi la separarea ultimă. Cred, nu știu, vedem. Bustiera, am înțeles burtică, what the fuck.
This telescope, and in particular we know that one face of the telescope cannot face the sun.
Ce bustieră?
That's why and to produce these right thermal conditions inside Webb, a specific roll law has been designed, what we call the sawtooth approach, and if you are watching.
Mai avem mult până, de fapt mai e până ajunge la ultima separare. Se pare că mai e. Mai sunt cam 170 de kilometri, cred. Da. Că arată în stânga.
To maintain this perfect thermal conditioning for the telescope.
It's worthwhile noting that after Webb separates from the upper stage of the Ariane 5 rocket, which continues to perform in excellent fashion at coming up on the 12 minute.
Stai mă că eu citesc pe unul foarte, foarte mic acum, deci am pe un. E atât de mic textul ăsta, chat-ul unde îl văd eu. Deci, vă dați seama?
The first steps will be the opening of fuel valves, a pair of fuel valves to start flowing fuel to Webb's onboard thrusters. They then will power on the valve drive electronics. Those are powered on in preparation to control and fire those thrusters when required. Webb's solar array is scheduled to be deployed at approximately the 33-minute mark into the flight. Once it is locked in place, we'll get the call that electricity is flowing through the array.
Bun.
That call will come from the Mission Operations Manager, Carl Starr, who's at the Space Telescope Science Institute at Johns Hopkins in Baltimore. Seated right behind him in that control room is Alicia Starr, a pair of stars helping to guide James Webb on its discovery of the stars. Alicia Starr is the lead engineer for launch and ascent events. Once the solar array is deployed and declared power positive, then 3 out of the 4 hold downs for the aft
Și abia aștept, Nicule, să descoperim noi. Abia aștept să vedem ce poate telescopul ăsta. E așteptat de foarte mult timp și chiar sper că o să fie bine.
From any water ice condensation as they cool down. The actuator drive unit will be powered on. This particular mechanism helps with heater control of the fine steering mirror, preventing water ice condensation later to be used to position each of the mirror's segments.
Sper că totul va decurge conform planului. Asta e, oricum, e un început, deja a fost lansat cu succes, lansarea a avut loc cu succes, acum mai urmează deployment-ul, adică desfășurarea telescopului, cum se va unfolding, nu știu, separarea asta de către rachete și punerea în funcțiune a tuturor modulelor. La o altitudine de 179 de kilometri, distanța de 3737 și urcă.
The range operations manager continues to report a nominal performance for James Webb. And again, Luce Fabriget from the European Space Agency, how is this trajectory being carefully and methodically adjusted to provide the correct parameters in the final stages of ascent?
Yes, Rob, as you can see on this plot,
the
altitude is slightly going down. It's perfectly normal. The launch vehicle is really on the line where it should be. This decrease of
slight
decrease of its altitude will allow the
El spune că e în 4K, dar îl folosesc în 1080p acum.
And to increase its velocity until it reaches a thermal threshold. It's about to reach it, or even already reached it now, and it will go up. And now it will go up and up to the separation of the Webb telescope. It will separate the Webb telescope on a highly elliptic orbit, but still around the Earth. The satellite, the telescope.
Nu știu, minizon. E probabil că acum, cu lansarea telescopului, lumea să se aștepte la mai multe lucruri interesante despre spațiu și ar trebui să, dacă se găsește viața acum în spațiu, ăsta e momentul potrivit care trebuie să ne explice dacă există cu adevărat sau nu, pentru că telescopul de asta e trimis în spațiu să vedem dacă suntem singuri în univers. Dacă încearcă să ascundă și acum, vedem. Hai ca exact la mea, da, e de Crăciun. Cănuța mea de Crăciun. Care este perioada vieții acestui telescop? 10 ani. A lui Hubble a fost de 5 ani și a durat 30 de ani. Acestuia este de 10 ani, dar e probabil să dureze chiar 40 de ani, depinde. Dar normal că îți dai seama că nu o să ne zică mai mult dacă află. Dar sunt anumite agenții particulare care au plătit pentru telescop și care au permisiunea să uite pe telescop și poate să dezvăluie ce găsesc pe telescopul respectiv. Sunt companii private, nu neapărat NASA. Deci, practic, nu o să ne spun NASA, dar o să ne spună alte companii dacă este cu adevărat viață în univers. Și ce găsește în univers.
Webb will be at an altitude of approximately 864 miles, statute miles, traveling some 21,000 miles an hour.
Apropo, dacă vreți să deveniți și voi membri ai acestui canal, aveți link-ul chiar în aveți chestia la la canalul de YouTube unde scrie Alătură-te sau dacă l-ai în engleză dă-i join și poți să beneficiezi de lucrurile pe care le spun acolo. Și deveniți membri ai comunității exclusiv. O să fie interesant. Și trebuie să lansez în 2100. Cred că următorul să lanseze undeva în 2300. Mai durează de ceva până la ultima separare, cred.
It's very important, Rob. The velocity you just mentioned at separation of the telescope is very important. It will be slightly below, okay, I give it in a kilometer per second, but it will be slightly below 10 km per second, because it's important that the satellite, the telescope, is not inserted on an escape orbit. It will be placed on a terrestrial orbit so that there will be time for the layup, for the early phase operations and the commissioning of the telescope. And that will be, in fact, the upper stage that will leave this orbit and goes toward an escape liberation orbit.
And of course, even though we're still in powered flight, the trajectory, the acceleration, the speed at which James Webb
Ați avut și o întrebare, a fost lansat telescopul? Da, a fost lansat, asta e, acum urmează ultima separare a telescopului de către racheta Ariane 5 și dacă decurge bine și ultima separare, o să fie totul în regulă. Deci asta e cea mai importantă separare a telescopului de către rachetă. Deci acum e important. Lansarea a fost un succes și așteptăm ultima separare.
18.5 minutes into the flight. It's very quiet now here in the control center here in Kourou. NASA officials, European Space Agency officials, Arianespace officials, all watching telemetry very carefully.
Nu uitați să lăsați și voi un like aici la videoclip. La live, pardon. Altitudinea este 260 de km, acum o să crească din ce în ce mai repede pentru că urmează separarea finală.
And as the upper stage continues to burn nominally and sheds fuel, the acceleration uphill for the James Webb Space Telescope continues to increase as we approach the 20-minute mark into the flight. Again, upper stage cutoff is scheduled at the 24-minute 51-second mark into the flight, about 5.5 minutes from now.
After the cutoff of this main engine, as you said, Rob, we will have a short
zice. Păi depinde pe ce vrei tu să dai. Ai mai multe opțiuni acolo. Eu te sfătuiesc să dai pe aia cea mai mică, cea mai micuță, cum ar veni pe funcție de membership, cea mai mică, nu trebuie să stai pe una mare. Și vreau să-ți dea voie, dar trebuie să spui, să streci datele tale acolo.
When there will be the separation, the conditions will be very smooth and as requested for the telescope.
Urmează ultima separare. Până atunci vreți să vă arăt geaca cu logo-ul de la Ai vrea să știi? Îi dau mereu like, îl meriți, paftă în continuare cu ceea ce faci, cu ce faceți. Mersi frumos, Florentina, te pup, apreciez efortul vostru de a mă susține aici pe canalul nostru de YouTube. Și l-avem și pe Robert. Robert e băiatul care face vocalele. L-ați auzit în foarte multe din videoclipurile mele. Deci el este băiatul care face vocalele la unele videoclipuri.
All parameters nominal as reported by Jean-Luc Voyer, the range
pe niciuna nu te lasă, ar trebui să te lasă, dar trebuie să completezi tu datele tale acolo și după aia te lasă.
4 minutes of powered flight remaining.
Ok, George, hai că-ți arăt imediat cum arată geaca cu logo-ul de la Ai vrea să știi. O am aici. Cam așa arată geaca. 2 secunde să vedem cum pot să fac. Și avem aici, Ai vrea să știi logo-ul. Dar nu știu cum să arăt eu că bate și lumina. Este o geacă oarecare, drăguță, și am vorbit cu cineva să-mi facă logo de la YouTube, de la canalul de YouTube și să scrie YouTube jos aici cu roșu. E foarte interesant. O să vă pun niște poze pe comunitate.
22 minutes into the flight. Less than 3 minutes of powered flight remaining.
Smooth flight control.
Și aș vrea și eu ceva cu logo-ul, ai vrea să știi. Cred că o să facem nu știu, vedem niște căni interesante, ar fi frumos. Îmi dați niște idei, tricouri. Nu prea să ved, dar o să vi-l arăt după aia mai bine, după ce se termină toată nebunia asta cu lansarea telescopului. O să vă arăt în întregime. E foarte frumoasă geaca. Geaca e cam second hand, dar e second hand, că am purtat-o, îți dai seama.
The launch operations manager announced the acquisition by the Malindi station, as expected, for the end of the flight and the last part of the upper stage flight.
Urmează, în câteva minute o să urmeze și ultima separare.
And again, at that point, it will be on its own. And again, those milestones that we discussed a bit earlier in the broadcast will begin to be followed carefully by the telescope controllers at the Mission Operations Center, the MOC as it's called, at the Space Telescope Science Institute in Baltimore. One minute of powered flight remaining. The upper stage continues to function perfectly. It's been a smooth ride for the James Webb Space Telescope.
Nu știu dacă o să vă apar acum, de exemplu, un hanoracul din design. Să vedem dacă se cum arată.
Trajectoire nominal.
Nu uitați să apăsați și voi butonul de like și vă mulțumesc pentru susținerea acordată.
That upper stage was loaded pre-flight this morning with 15 tons of propellant for this long 16-minute burn.
Măcar un sticker de lipit pe telefon mă mulțumesc și cu atât. O să fac niște stickere, sincer, chiar voiam să fac niște stickere interesante cu logo-ul. Bine, o să bag și mai multe chestii, că vreau să fac niște quote-uri interesante despre spațiu și mai multe. O să dacă totul decurge conform planului, o să fie extraordinar. Separarea acum trebuie să facă. Gunoaiele spațiale nu deranjează ceilalți sateliți sau telescope? Nu deranjează, pentru că e o distanță foarte mare între gunoiul spațial și nu are nicio treabă, nu ajunge la să deranjeze nimic, cum ar veni.
As expected, with the exactly expected altitude and speed and velocity.
Mulțumesc frumos, George. Apreciez foarte mult susținerea voastră. Mă bucur că vă place ceea ce fac și că sunteți alături de mine aici. E bine că ai făcut-o și pe aia să abonezi. Ai corupt-o.
All of the function parameters for the James Webb Space Telescope have been loaded on board the telescope. We are expecting Webb separation at the 27-minute 7-second mark here into the flight. Just over a minute from now, springs will gently push Webb away from the upper stage of the Ariane 5.
Mai este 1 minut și câteva secunde până la separarea finală a telescopului față de racheta de vârful rachetei Ariane 5. Cu ce este filmată de aproape naveta în spațiu? Asta este o animație făcută, o animație făcută de către NASA, o simulare. Cu plăcere, Valentin. Gunoaiele spațiale sunt foarte îndepărtate unele de altele, așa că nu deranjează cu nimic noile lansări în spațiu. Ai auzit de joculețul KSP ar merge un episod să o studiez despre lansări de rachete și foarte interesant. O să mă interesez, Loren, mersi frumos pentru informație. O să mă interesez. O să-l scriu pe ceva. Imediat 2 secunde ca să-l țin minte. Perfect. Respect cameramanului. Da. Zboară lângă racheta. Nu minizone. Haideți că ultima separare este gata. Deci este un fake. Nu este un fake, este simulare în timp real. Adică simularea în timp real înseamnă atunci când telescopul... Gata. A fost bine. Deci a fost bine. Separarea a avut succes.
We do have confirmation of observatory separation. The James Webb Space Telescope, amidst applause here in the Mission Control Center, now taking its first steps in pursuit of cosmological discovery.
Bun. Perfect.
It was a perfect ride to orbit. And all
acum avem imagini din telescop, de la telescop în spațiu.
Running in good fashion according to the telescope controllers.
Perfect. Acum vedeți. Asta e camera exterioară a navetei Ariane 5. Uitați telescopul cum zboară în spațiu. Deci am pielea de găină acum. Pur și simplu mi s-a făcut pielea de găină. Holy shit. Bravo. Bravo. Am și o întrebare, dacă s-au tot lansat atâția sateliți ce orbitează Pământul, de ce de pe stația spațială nu se văd? Ba se văd, dar nu le face în mod special poză, pentru că stația spațială este mai sus, în partea exterioară, sateliții sunt undeva mai jos. Să zicem la 1.000.000 de mile, adică undeva la 2,7 milioane de kilometri față de Pământ. Deci avem un nou telescop în spațiu, ceea ce sunt foarte încântat. Perfect. Ce-i cu staniolul ăla? E făcut ca să-l gătească mai bine în spațiu. Ne apucăm de gătit în spațiu. Crăciun fericit și sărbători fericite alături de cei dragi, by the way. Mersi frumos, mersi, mulțumesc la fel. Crăciun fericit ție, sărbători excelente și să vă aducă noul an numai fericire, sănătate, pentru că e foarte importantă, și să aveți grijă de voi și de familia voastră, pentru că asta e cel mai important, familia. Și voi, ca și oameni, să aveți sănătate. Așa că aveți grijă de voi. Nu uitați că dacă vreți să intrați pe serverul de Discord, îl aveți în descriere. Dacă nu, vi-l las aici pe chat. Dacă vreți să vă alăturați și voi serverului nostru de Discord, acolo mai discutăm chestii interesante, mai vorbim despre spațiu și despre mai multe chestii. Vă dau imediat invitație să aveți și voi
James Webb not only has legs, but it has power as it begins its journey in the commissioning activities to follow. And with that, let's go down to the floor in the fishbowl, and Raphael Gervais of Ariane Space.
Nu uitați să intrați și voi aici pe Discord dacă vreți să discutăm. Aveți serverul meu de Discord aici, vi las în chat. Crăciun fericit și abonați cât mai mulți. Eu intru un pic mai târziu, că mă duc să înfuleg ceva. Poftă bună, George, mersi pentru că ai stat alături de noi aici pe Discord, pe live. Nu uitați să dați și voi acolo join pe serverul de Discord. Vorbim mai multe chestii acolo, o să fie interesant. Da, greu la trecut. Acum urmează partea ușoară, adică unfolding-ul. Sperăm că totul să fie bine. Asta a fost tot. Acum vedem... Cred că asta a fost tot, bănuiesc, nu? Turco Elena, mersi pentru sub, bine venit pe live-ul nostru. De ce nu trimiți tu ceva la NASA? N-am ce să trimit la NASA eu. Nu mă bagă cei de la NASA pe mine în seamă. Am trimis un mail lui Elon Musk, de fapt un mail, am trimis mai multe mail-uri, că poate intru live cu el și ar fi, vă dați seama dacă aș intra live cu Elon Musk, ce ar fi? Holy shit, ar fi ceva senzațional. O să iau un interviu cu directorul operațiunii și gata. Da, da, da. Deci totul s-a lansat cum trebuie, lansarea a fost un succes. Știi că acest telescop nu se poate repara în caz de strică ceva. Normal, știm că nu se repară. Din cauza asta, cei de la NASA au făcut în așa fel încât să, dacă se strică ceva, să au ceva de rezervă. Cred că urmează deschiderea oglinzii de aur aia de 6,5 metri. Da, da, mai durează până o să fie deschisă oglinda. Mai durează ceva. Mai durează ceva timp până o să fie deschisă oglinda. Dar ce a fost mai greu a trecut, acum practic urmează părțile mai ușoare.
Sunshine on Webb solar panels as
2 secunde să-mi iau telefon.
into space on its journey to its working zone. It's going to take about 6 months before we start getting our deep space observations from Webb. Of course, the teams have got a huge amount to do before we get to that, and our best wishes with all those teams in Baltimore. I want to get some reaction. Right now everybody's talking and hugging each other because they're feeling so excited, and I totally understand that. Let's start though by going over to the NASA administrator, Bill Nelson.
Am zis că oglinda se deschide peste 30 de zile, s-ar putea să deschidă chiar mai târziu, depinde. Da, oglinda se va deschide într-o lună, după aia până își va pune toate instrumentele în funcțiune, va dura în jur de între 3 și 6 luni, depinde. Dar a fost interesant, mi-a plăcut. Lansarea a avut succes. Nu uitați să vă lăsați și voi un like.
Okay.
Iulie 2022 va fi full operațional. Dacă va fi în iulie, dacă am 6 luni, ar trebui să fie. Depinde cum se va descurca. Nu, i-a plăcut, asta a vrut să zică, că i-a plăcut, adică a stat cu sufletul la gură ca totul să decurgă cum trebuie. Sper că totul să funcționeze perfect. Și eu la fel sper, Florentina. Eu sper că până acum a decurs cum trebuie și na, o sunt curios și va descoperi. Și eu sunt curios, crede-mă. Sunt foarte curios. Sunt foarte curios pentru că îl aștept de, v-am zis, îl aștept de 4 ani, de când, în 2017, de când a fost programat să fie lansat și a fost anulat până în 2021. La sfârșitul anului 2021, vă dați și voi seama. Gen a fost anulat că trebuia să fie anul trecut în octombrie, trebuia să fie anul ăsta în octombrie și a fost anulat, trebuia să fie pe 22 și a fost anulat până pe 25. Deci vă dați seama. Dar totul a decurs conform regulilor și mă bucur că avem un satelit, un telescop nou în spațiu. Foarte frumos. Foarte, foarte frumos. Deci chiar mă fascinează uneori. Nu uitați să vă lăsați și voi acolo un like la live. Și cred că o să închidem live-ul, pentru că o să trebuiască să mă apuc în curând de editare, că trebuie să editez niște videoclipuri. Și o să ne auzim în următorul videoclip și poate cine știe, o să mai facem live, probabil cu noi informații despre telescop. Și ce să zic, abia aștept și eu să fac videoclipuri despre descoperirile pe care le va face James Webb. Și ce să zic, un an nou fericit, Crăciun fericit tuturor, sărbători fericite, alături de familie și de cei dragi. Vă mulțumesc că ați stat cu mine până acum și ne auzim în următorul live. Nu uitați că puteți să vă alăturați canalului nostru de YouTube. 2 secunde să vă dau dând click aici pe linkul ăsta, puteți să vă alăturați canalului de YouTube, să deveniți membri exclusivi. Aveți anumite beneficii, mă ajutați și pe mine foarte mult și vă apreciez foarte, foarte tare că ați fost alături de mine. Sărbători fericite! Aveți server de Discord în descriere, ne auzim și acolo, lăsați mesaje. Și dacă vreți să aveți acces direct cu mine pe Instagram, pe Facebook sau restul, aveți mai multe informații în secțiunea de Alătură-te la membrii canalului. Și dacă aveți nevoie de ceva, mă găsiți întotdeauna acolo. Vă pup, zi frumoasă aveți și distracție plăcută în continuare.